So a ship sails from point A is shown here, to point B, which is 15 kilometers from A on a bearing of 42 degrees. The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey, right? So on the diagram, insert the bearing 42 and 130, right? So the ship is going from A to B on a bearing of 42 degrees, right? So I want to point out to something as to why I cannot put B here, right? The reason I cannot put B there is because the bearing of 42 degrees could never be this, right? So that's why I know B is up here. So the bearing of B from A is going to be 42 degrees. They said from B to C, it's 19 kilometers away and it's on a bearing of 130 degrees, right? So your bearing on this side is going to be, you're heading to C and you're coming from B, it's going to be 130 degrees, right? Now let's put in the lengths or the distances that each ship is traveling, right? 15 kilometers. And how far would this distance be here? This is up to C. This will be 19 kilometers. Everybody good there? Right? So your ship move from A to B on a bearing of 42 degrees, then it move from B to C on a bearing of 130 degrees, right? To draw each bearing, you start at your north line and you always go in a clockwise direction. You realize I'm only going that way, right? You always go in a clockwise direction, right? So we inserted these two things. That is done. Calculate the distance between tongue A and tongue C, right? So we want this distance down here, okay? We have this length, but we don't have the angle within the triangle. What can we do? Are you all seeing that this angle here, 42, and the angle that's on this side here are what type of angles? Co-interior, brother. Yeah, come out for them, right? Co-interior angles add up to how much degrees? Add up to 180 degrees, right? So this angle here, let's call it X, and this angle here, 42, add up to 180 degrees. Right, so co-interior angles, for those who not seen it, right, it's basically like you have two parallel lines. You have a transversal going from one parallel line to the next. The angle on the inside here, let me call it A. The angle on the inside here, let's call it B. These two angles add up to 180 degrees. So if you have one, you can get the next one. Cool? So let's find X. 180 minus 42 because the two angles add up to 180 degrees, right? 138 degrees, right? We then need to proceed to find the angle that is in the triangle. That is the only way we could find the side which is opposite to this angle. It will be A to B to C. Would be equal to the complete revolution would be 360 degrees, right? 360 minus 138 plus 130, right? Let me give you all a visual there. A complete revolution, right, around any point will be 360 degrees. So 138 plus 130 plus the unknown angle will all add up to 360. If you want to find this angle, you simply add these two, minus it from 360, you'll get the unknown angle, right? Right. Now we could find the distance between tongue A and tongue C, right? So the distance between tongue A and tongue C. So I'm going to put on the side here. We have two sides, one angle. We found here to be 92 degrees, right? One angle, and we want to find another side. What are we using? Whole week we're doing this cosine rule. Right? You all saw the videos that I sent Junior week? That will be A squared is equal to B squared plus C squared minus 2BC cos of capital E. Right? That is only when you have a triangle that is not a right angle triangle, right? So in this triangle, let's call here A. that will be the angle. Opposite the angle will be the common E, right? Then here will be capital B, opposite capital B will be common B. Here will be capital C, opposite capital C will be common C. Let's give it some perspective to the question above. Here's capital B. It's a little different for this one, right? Here's capital B, and the side we are trying to find is common B, right? CXC puts these things to really test your understanding of the question, right? So this is common B, and in this question, here's capital here E, here's common E, here's capital C, here's common C. So watch it, this is where you have to lock in, right? For the formula, capital A is the angle you have. Common A is the side you're trying to find. Common A is the side you're trying to find, which is, let me call it AC. So AC squared is equal to, now common B and common C would be the two sides that we were given. But look at this here. In this question, common B is actually the side we're trying to find, right? So you know common B and common C are the two sides here, 15 and 19. Right? 15 squared plus 19 squared minus 2 by 15 by 19 cos capital A, which is the only angle in each angle, 92. Right? So you're going to come right here. So AC will be equal to the square root of what? What do you get when you work out this whole thing as 1? Right? When we write the answer, we'll go to one decimal place, right? So therefore, AC will be equal to, give me to one decimal place now.
24.6.
24.6, and this is kilometers, are we correct? Right? And I want you to put to 1 dp. We're going to 1 dp, but we just had to write it in, right? So determine the bearing of tongue A from tongue C. What is most important when we doing bearings? I said it all week in all the videos. The most important thing is where we are coming from. Where we coming from? Tongue C. We go in, your bearing, you start at your north line, brothers and sisters. You start at your north line and you go in a clockwise direction all the way around to the line that goes from C to E. Would be the angle within each angle, and then here would be another angle that we need to find, right? So once you add up these two angles together, minus it from a complete revolution, which is 360, I would get the bearing of tongue A from tongue C. The same thing that happened here, right? Which is boom, bang, 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 right? Co-interior angles add up to 180. The same thing is happening on this side. Are you all seeing the co-interior angles? Y and 130. So I can't find Y, right? I will use just 180 minus 130 to find Y, and then I'll need to find Z. What this side was? Anybody have it there? 24.6, right? And this is kilometers. So you could use this angle and this angle and this side opposite it, right? Sine rule is dealing with pairs. We're going with sine rule, but let's find Y first, right? Y will be equal to 180 minus 130, which will be how much? 50 degrees. To find Z, watch this, right? I have two sides, right? Look at it. I have two sides, one angle in each angle, and I want to find another what? Angle, right? So once you're dealing with pairs, watch, pairs. Two S's, one A, you want to get our next E. This is sine rule. Okay? If you have two angles, right? One side, and you want to find our next side pairs, you use sine rule, right? Cosine rule, the only other condition for cosine rule would be you have three sides, and you want to find the angle. That's why we say you could use cosine rule here, because you see you have three sides and you want to find the angle. But I gotta use sine rule because I just want to work sine rule, right? So let me go. This will be capital C, here will be common C, this will be capital B, this will be common B, right? So sine rule, because some people see this for the first time, this will be common A over sine capital A will be equal to common B over sine capital B, which is equal to common C over sine capital C, right? Same triangle that is not a right angle triangle, is what this applies to, right? If here's capital A, here will be common A. If here's capital B, here will be common B. If here's capital C, here will be common C. Using C, capital C, common C, right? So it will be, remember we calling the angle Z. So we sine of Z underneath because we calling the angle Z, right? The side is 15. And this will be equal to the other side and angle that we're looking at will be 92 and 24.6, right? Over sine of the angle, which is 92. I'm carrying the whole sine Z over here, and I'm bringing this whole thing where sine Z was in one movement. It's like you're swapping it, right? So this will be 15 over 24.6 divided by sine of 92, right? And this will be equal to sine Z. Okay? So, I want somebody to work out this summer. You're punching on your calculator, 15, press the division sign, try there, bro. So when you work out 15 divided by 24.6 divided by sine 92, you put in brackets everywhere. So you will get 0.609, right? I put it at 3 decimal places because we actually have to find sine -1 of that, right? So at this point now, you're carrying the sine over here and you're doing the opposite of sine, which is sine -1 of 0.609. What remains on the right hand side? The Z. And this will be degrees is equal to Z. But did the question ask us a Z or did the question ask us a Y? Right? No, the question asks us the bearing of A from C. Where you're coming from is where your bearing would be located. So you go in a clockwise direction to the line that goes from A to C, right? So we found Z, we found Y. Let me put them in here. So add up to the 7.5 and 50 minus it from 360. 360 minus, it was 37.5 plus 50. And we're getting 272 what? And this would be our bearing, so it will be degrees. The point L, M, and P lie on the circumference of a circle whose center is O, right? So you have you have L, M, P, right? All of them are on the circumference of this circle, right? They said line N to P is a tangent. So this line, even though they stop it there, this line actually extends all out here. Cool? Right? It's a tangent to the circle at P. It means the only spot that this tangent will touch this line would be at P here. Is everybody clear there? Right? And O, M, N, O to M to N is a straight line. Right? The line PL is a diameter, PL, you've seen PL here, diameter, and angle O to N to P is 24 degrees, right? Let's see what the question is asking us for. Calculate the value of each of the following angles, show detailed workings where necessary, and give a reason to support your answer. So you have P to O to N. This bad boy here, right? In order to find that angle, the theorem that I need to engage is where a tangent and a radius, because a line that comes from the center of the circle to this circumference here, right, which is actually where the tangent and the radius meet, would be a 90-degree angle, okay? And followed by that, the next fact we'll have to use here is that the three angles in a triangle add up to. So let's first put that N PO would be equal to 90 degrees, and you must put the reason, right? When a 90-degree angle is formed, right? Everybody good here? So now PON would be equal to 180 minus 90 plus 24, right? When you add these things together and minus it from 180, what are we getting?
66.
So this will be equal to 66 degrees. And you must place the fact that the angles or the three angles 180 degrees. Right? So the theorem, once again, the theorem we're going to use here to find part 2. Right? So part 2 was to find PLM. PLM, P to L to M would be this angle up here. So angle at the center is twice the angle at the circumference. So if here is 66, up here will be 66 divided by 2. Right? So PLM would be equal to 66 divided by 2, which is 33. Right? And the reason will be angle. So in order to find PMN, I'm going to find OMP first, right? Which is this angle here, right? To find that angle, because this is an isosceles triangle, this is two radii here, 1, 2. I'm going to do 180 minus 66 divided by 2, and I'll get this angle here. So OMP will be equal to 180 minus 66 divided by 2, right? And this is where we will get 57. And 114 divided by 2 will give me 57 degrees, right? That is OMP, right? That is OMP, which is 57 degrees, right? And then the two angles at a point on a straight line add up to 180 degrees, right? So in order to find PMN, so therefore PMN would be equal to 180 minus 57, which would be 1, 2, 3. 1, 2, 3 degrees, right? So let me put some reasons here. The reasons for this was base angles, triangle are equal, right, at a point add up to 180 degrees. So V, X, Y, and Z lie on the circumference of the circle shown below. Center O with diameter VY, right? V to Y is the diameter, right? UW is a tangent to the circle at V. So you have UW tangent to the circle at V, meaning that it touches the circle at one point here, V. Then angle VXZ, V to X to Z is 62 degrees, and then they said angle XVY, X to V to Y is 18 degrees, right? So the first thing they want you to do is to state a theorem that justifies the value of each of the following angles, right? So B is equal to 62 degrees, right? The justification for that will be angles. So you're right. So angles at are equal. C is 124 degrees. That's this angle here. Angle at the center is twice the angle at the circumference, right? The theorem is right here. So let's write that in. This should be right not in long time. Angle at the center at the circumference. So part C, they want us to find angle OVW. State the theorem, right? OVW. O to V to W is 90 degrees. Why? Where A, when a tangent and a radius meet, a 90-degree angle is formed. I say it again. Angle between a tangent and a chord is equal to the angle in the alternate segment. On this side, same thing applies. Angle between a tangent and a chord, this is another chord, is equal to the angle in the alternate segment, right? Okay? So, this angle A will be equal to the angle in the alternate segment. A is equal to 62 degrees. Angle between the alternate segment. So C was 124. We have two radii here, 1, 2. these two angles will be equal. Base angles in an isosceles triangle are equal. D is equal to 180 minus 124 all over 2. And we're getting there. Right? And the reason will be base angles. Please put my reason. An isosceles triangle, you basically have two lines that are the same here. These two lines are the same. These two base angles here would be equal. A is equal to B. You're seeing that if I could find, no, well, I had this angle here, right? I had D. What we just found out D to be 28, right? So this angle here, which is 18, and this angle will be 90, right? Everybody clear there? So once you can find this angle here, the angle between a tangent and a chord is equal to the angle in the alternate segment, right? That'll be equal to the whole angle here. So you still have to minus 28 from it to get E. So the first thing I'm going to find would be XVW, which is equal to 90 minus 18, right? XVW is equal to 90 minus 18, which is what? What you all got here? 72 degrees, right? And therefore, E would be equal to 72 minus 28. I was trying to remember the 28. And we're getting here? 40 who?
44.
44 degrees will be my final answer. So the diagram below shows a quadrilateral P to Q to R to S formed by joining two triangles PQRS, well, PQS and QRS, right? Calculate the length of QR. We want here. Come now, that food. You have two sides. You only need two sides. One angle, and where you want to find the next side, right? You have two sides, one angle, and you want to find the next side. What we using? Cosine rule. That's food, eh? Belt or that. I want my answer there one time. Capital A will be the angle. Common A will be the side we're trying to find, right? Common B will be this. Common C will be this, right? Minus 2 by 18 by 16 cos of capital A, which is 25, right?
57.97.
96897. Like, look at that, right? Hit my man, say here. We ain't come here to play. 7.6 to one decimal place, right? And this will be what? Meters to 1 dp. So the bearing of P from S, I said it whole week, I said it. What is the most important thing when you're dealing with bearings? Where you are coming from. We're coming from S. So that's where my north line going to be. Wherever S is where my north line going to be. And they said this bearing is 205. Determine the bearing of R from S, right? So let me locate this bearing first, right? You're putting the north line by S. You're going in a clockwise direction to the line that goes to P. This is your north line. Okay? And it's going to be the angle that goes from S going all the way to P. So that's all this bacchanal here. All. Right, let go. So 205. So if I want the bearing of, let's watch it. I want the bearing of R from where? From S. Okay, so that bearing is located at S. Is going to be clockwise going to the line that goes to R. That bearing, you start at the north line and you're going to the line that goes to R. Cool? So if this whole thing is 225, this little piece here is 25, this piece here is 72, what this piece here will be, my children? Dog food. That's what we just call that. It would be dog food. Right? So we go in the bearing of R from S will be equal to 205 minus 72 plus 25. You sure? What we getting? So we want the bearing of S from P. Where we coming from is the most important thing. So that's where we draw our north line, right? We coming from P. Where P, right? P down here. Right? You need to get this up here. Right? Very good, Kyle. So you're getting this angle up here. Right? Co-interior angles add up to 180 degrees. So, how do we get here? We want to get this angle here first, right? That angle, we call it PS n, right? We'll call it P to S to N. That is 360, which is the complete revolution, right? Minus 205 would give me this piece. P to S to N, right? That will be equal to 360 minus 205, right? And this will be equal to 155 degrees. Therefore, the bearing of S from P would be equal to 180 minus 155, which will give me how much? 25 degrees. So number 9 in June 2023 now, right? So L, M, N, and R are points on the circumference of a circle with center O. Boom, L, M, N, R, right? PQ, which is this line on the exterior of the circle, is a tangent to the circle at R. When I say at R, it means that it touches the circumference of the circle at only one point. Preston, you with me? Right?
Yes, sir.
Okay, angle PRL is equal to 48 degrees and angle RON is equal to 156 degrees. Now, so find the value of each of the following angles given reasons for each of your answers. Show all workings where appropriate, right? So angle R is here. Okay? So that theorem would be angle at the center is twice the angle at the circumference. So let's just put the working there and write the reason, right? So this will be equal to 156 divided by 2. What is? 72. 78 degrees. Reason will be angle at the circumference. Right? So if we want to find E, we already have R. Follow my arrow to see the triangle, right? Boom, bang, bang, right? Angle between a tangent and a chord is equal to the angle in the alternate segment, right? So if you have, in this case, we don't have E and want R, we have R and want E, but it's the same thing, same theorem. E would be equal to 78 degrees, right? And we're going to put our reason. So E is equal to 78 degrees, and the reason will be angle between alternate segment. So the next part of the question is to find angle E, right? So angle A is this angle up here. How do we find angle A? We first find this angle that is highlighted in blue here. Angles at a point on a straight line add up to how much degrees? 180. So when you add 78 and 48, you minus it from 180, you will get this angle in blue here, right? Then we proceed to say opposite angles in a cyclic quadrilateral add up to 180 degrees, right? So this angle in blue and this angle over here would add up to 180 degrees. Let's work. So I'm first going to put L to R to N. To R to N is equal to 180 minus what was 78 plus 54 degrees, right? Angles at a point to 180 degrees, right? Proper? So now we need to find A. So therefore, A would be equal to 180 minus 54 degrees. And how much you getting here? 126. And this reason would be opposite angles. So there's a little visual on the cyclic quadrilateral, right? How many sides does a quadrilateral have? 4. 4 sides, 4 vertices. All 4 vertices must be touching the circumference of the circle, right? Okay, all 4 vertices. So that means that this angle here and this angle over here, let me call it A and B, are not the same. They add up to A plus B, add up to be 180 degrees. So if you have 1 you have the other. You just have to minus it from 180 and you will get the other angle, right? So what we found here to be 54, and the angle opposite, you're looking at the bigger quadrilateral here, which is out here, right? This angle and this angle here would add up to be 180, okay? So this will be opposite, right on the theorem, opposite to 180 degrees. The diagram below shows a triangular field LMP. L to M to P. It's a triangular field, so that means this flat on the ground, right? This flat like this, boom. Calculate the value of angle M to L to P. So you want M to L to P. That's this bad boy here. So you have three sides, and you want an, what are we using?
Cosine.
Come on, man. Come on. This is food now, man. Remember, sine rule is pairs. 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 Sine rule is two sides, one angle. Yeah, what the next side? I mean the next angle, sorry. Right? Two angles, one side. Yeah, what the next side? Pairs. This is sine rule. Two sides, one angle, and then what the next side? Right? You realize it's not pairs. This is cosine rule. Calculate the value of angle MLP. We line up the formula here one time. A squared, which is the side opposite the angle we're trying to find in this case, is equal to B squared plus C squared minus 2BC cos of capital A, right? Capital A is the unknown angle. We'll call it MLP, right? So we know what A is. A is 180 squared equal to B. B could be anyone, eh? Right? B could be 150 or 120, right? So 150 squared plus 120 squared minus 2 by 150 by 120 cos of capital E, right? So you see this bad boy here? I want you all to work out this, and then I want you all to work out this, right? We put everything back in place, then we will function from there, right? So let me go. 180 squared is what? 36,000 cos of E, right? So compose yourself, right? What I'm going to do, we could carry this here. This is positive, right? This is plus. So when it goes there, what it becomes? So 32400 minus 36900 is equal to, is still negative here, negative 36000 cos of capital E, right? We got this here.
Negative 4,500.
Hey, let's bring this here one time now. What we do with it when we bring it here? Multiplication is understood here. The opposite of multiply is to negative 36000 is equal to cos of capital E. Alright? So at this last point here, we want to carry the cos here, do the opposite of cos, which will be the inverse of cos. Right? So cos negative 1 of, let me cancel some zeros here now. So negative divided by negative is a positive. I'm simply going to put 45 over 360. And this will be equal to capital E. Right? Let's work. Therefore, A will be equal to what? 82.81. I put 82.8, right? Degrees to 1 dp. We ain't come here to lose. So the bearing of P from L is 210 degrees. So we are coming from L. So my bearing of 210 is going to be a line that, well, an angle that starts at the north line, goes in what? Clockwise or anti-clockwise? Clockwise direction, going straight to the line that goes to P. Of L from P. You see the line going to P here, right? So you're starting here. You're coming around here. You're joining up here. And you're going here. 210. Right? When we just find here, and we just find in here, what this was? Hit me, 80 something.
82.8.
Find the bearing of M from L. So this is where my north line going to be. It's going to be where L is. So wait now, they just want this. They want you to stop here. They want this piece here. Proper. We get 127 what? And this will be degrees. Calculate the value of angle NLP and hence find the bearing of L from where? P. So from P we go into L, right? But we have to calculate this angle first, NLP. Let's locate NLP. N to L to P, that's this bad boy here. They want L from P. So you're coming from P. So the north line is going to be where you're coming from. So they just want this. This is food. 360 take away 210. And then these are co-interior angles. But let me put PLN first, because that's the first thing they ask us to find. PLN or NLP, right? Is the same thing. NLP would be equal to 360 minus 210, which will be 150. Yeah. And therefore, the bearing of L from P would be equal to 180 minus 150, which will be 30 degrees, right? I'm not going to say what looking wrong here. So this is June 2022, number 9, right? H, J, K, L, and M are points on the circumference of the circle with center O. H, J, K, L, and M are all on the circumference of the circle, right? MK is a diameter of the circle. So you have from M to K, that's a diameter. And it is parallel to HG. So you see HG up here, these arrows indicate that these lines are parallel, right? MG, where's MG? This is MG is equal to GL. GL is down here. These two lines are equal. They are indicated by these two strokes, right? So they said the only angle they gave us was JMK. J to M to K would be 38 degrees. They want you to explain, given a reason, why this angle is equal to 38, right? So if you observe, we have a pair of parallel lines here. This angle on the inside here would be equal to this angle on top here, right? And the reason would be alternate angles are equal. Then we have a pair of parallel lines like this, boom, bang, and you have a transversal running from one parallel line to the next. This angle on the inside here would be equal to this angle on the other side here. So you have alternate angles equal. Next, they want us to give a reason why MJK is equal to 90 degrees, right? Follow my arrow. M to J to K would be this entire angle here, right? And the theorem for that would be what? So angle in a semicircle is 90 degrees, right? So watch it. You have a diameter busting through the center of the circle, right? Once you have an angle being formed of this diameter, right, and the vertex up here touches the circumference of the circle, this will be a 90-degree angle, right? I can do the same thing down here. Boom, bang. 90-degree angle, right? The theorem is angle in a semicircle is 90 degrees. Anyhow you draw this triangle, you would get 90. Determine the value of each of the following angles. Show the tail workings where appropriate, right? So we're going to deal with angle M to L to J first. So let's locate angle M to L to J. Good. MKJ would be the first angle we have to find, right? When we find M to K to J, we add 90 and 38, you minus it from 180, you get here, right? When you get here, angles at the circumference in the same segment are equal. So MKJ, M to K to G would be equal to 180 minus 90 plus 38, right? And then when we work out this, what we get? Who have it there? 50 how much? 52 degrees, right? I'm scrolling back up to show you all. That would be this bad boy here, 52 degrees. And then we can say angles in the same segment are equal. You all see the butterfly here? Boom, bang, boom, bang. That will give us angle M to L to G, right? That's this angle here. So this angle will be 52 degrees. And the reason will be angles at the circumference in the same segment are equal. Alright? So the next part is they want us to find angle L to G to K. Right? L to G to K is this little angle here, which is L to G to K. I'm going to first identify that these two base angles here in this isosceles triangle are equal, meaning that this entire angle here is 52 because here was 52, right? Then I will find this angle which is LMK, right? MLK, which is here, will be 52 minus 38, which will give us how much? 14? 14, and then therefore LJK will be equal to 14 degrees also. So in order to find LJK, I first needed to identify that LMG is equal to 52 degrees. Reason for that would have been base angles in an isosceles triangle are equal, right? I proceeded to find LMK, which was 52 minus 38. That gave me 14 degrees. This would now imply that LJK is equal to 14 degrees, and the reason for that will be angles in this at the circumference in the same segment are equal. Alright? So the next part of the question is to find JHM. So the law here will be opposite angles in this highlighted cyclic quadrilateral would be adding up to 180 degrees, right? So these two angles, this one and this one, add up to 180 degrees. We already have here 52. So part B, from A port L, right, ship R is 250 kilometers on a bearing of 65 degrees, right? So from port L, what is the most important thing about our bearing? Where you are coming from. So we come in from port L, right? And it said the ship is 250 kilometers on a bearing of 65 degrees. How do we draw a bearing? If you're coming from L and your bearing is located at L, you start at the north line and you go in what direction? Clockwise or anti-clockwise? Clockwise. So you go in a clockwise direction to the line that goes from L to R, right? So that would be my bearing of 065 degrees, right? Ship T, look, ship T down here, is 180 kilometers from L on a bearing of 140 degrees. What's the most important thing about our bearing? Where you are coming from where? L, same L, right? And the bearing is 148 degrees. So you start at the north line that is located at L, and which direction do we go? Clockwise or anti-clockwise? Always go clockwise our bearing. So you're going bup, 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 and you're going straight to the line that goes from L to T. Everybody see? That bearing is how much degrees? 148 degrees. The angle R to L to T. So watch it here, right? I'm going to do it in a different color. R to L to T is this angle inside here. How do we find this angle inside here? If the whole thing is 148 and this piece is 65, I can do 148 minus 65. How much degrees that will give me? 83 degrees is what RLT is, right? So this is part one right here. No, that's all. So the next part of the question, we want to find RT. Okay? RT would be the side that is opposite to the angle that we just found, right? So if I have two sides, S and S here, one angle, and you want to find the next side, I am using my cosine rule. What is my cosine rule? It is given right here. So we have RT squared, which is common A. The side we're trying to find, common A, will be the side that is opposite to capital A. Everybody good here? Here will be common A, this side RT. So RT squared would be equal to common B, which is 180 or 250, don't matter which one you put first, right? Minus 2 by 180 by 250 cos of the angle. What is the angle we just found up there? Look at it right there. The angle is 83. Come on, guys. How much? 83,931 point. Go to two decimal places. 76 proper. And therefore, RT, which is the side we are trying to find, the distance between the two ships, would be equal to 289.71 0.71. Yeah, give me two decimal places, right? Kilometers, right? So just to reiterate, my children, we are finding this angle here. This angle, right? So what I'm going to do is I'm going to use sine rule. So I'm engaging this angle with the side that is opposite it. That will be a common R, right? Now I did put capital A here, so I just put common A there, right? So if we're using this angle, which is 83 degrees, we would be using the side that is opposite the angle, which is 289.71, right? Kilometers. So that is exactly what I did here, right? I put this here was common A, and this was the capital A, the angle, right? So 180 is the side, capital R is the angle we're trying to find. So what we're going to do, I carrying this over here, just like what I did yesterday, right? You're carrying sine R to the right, you're going to multiply it. So what that means is that this whole thing, you could fling it on this side, right underneath there one time, in a one, right? So what you're going to look here, sine R would be equal to 180 is on top in my numerator position, all over 289.71 divided by sine 83. This underneath working there must be in brackets when you type it on your calculator, my children. It must be in brackets. Otherwise, you won't get the correct answer. Right? So there we go. Let me work. Hit me there. Yeah, you have to. We can come here to lose, boy. Come here to win. When you work out this, right, you put in 180, press division, you must open your bracket, right? Open a bracket, 289.71 divided by sine 83, close your bracket, right? Press equal, you're supposed to get 0.617, right? Then I need to carry sine alone here. One sine moving by itself without any angle, which is like R or whatever, you change sine to the opposite of sine, which is the inverse, right? So this will be R is equal to sine -1 of 0.617. What is the value of R? So 38.07 degrees to 2 decimal place. The question asks me to find the bearing of T from R. So let me put up here. So therefore, the bearing of T from R would be equal to 360 minus 115 plus 30 30 how much? 38.1. 38.1. We run it 38.1. So again here, one time.
206.9.
206.9. And this is our bearing, so it's degrees. We found here to be 38.1, right? Or 38.09, okay? But the one decimal place is 38.1. And we have here as 115, the complete revolution is 360. The complete revolution is 360. So to find, you're starting at the north line, you're coming in a clockwise direction, this is the bearing, right? So the bearing would be 360 minus the sum of these two angles. That's what I did, right? Okay? So we on to 2021, number 9, right? Let me read. So in the diagram below, E, C, G, G and F are points on the circumference of a circle. EG is a diameter, right? So E to G is a diameter of the circle. Tangent AEB, A to E to B, is parallel to C to D, right? Angle AEC, so where's AEC? A to E to C is 68 degrees, and angle EF to D is 106, right? Lucky, nah? Determine the value of each. Somebody mic on. Yeah, go ahead. All right, let me go. So, they want us to determine the value of each of the following. Show detailed working where necessary and give a reason to support your answer. So, I'm trying to find angle E to C to D, right? That is this bad boy here. So, this question basically had a mistake, and AEC supposed to be 74 degrees. Here is supposed to be 74, right? This angle here is supposed to be 74 degrees. So let's work the question with there being 74. So if here is 74, that means this angle up here, which is what they're asking for, would be 74 degrees, right? So we're working it at 74. That's the correct thing, right? And we could just say alternate are equal. Simple, right? So next we want to find CEG. C to E to G. That'll be this piece here. Right? So where a tangent and a radius meet, what kind of angle is formed? So you realize this 68 had affected the answer for the first question, and it would affect this answer too. Right? So this will actually be 90 minus 74, but you must put the theorem where a tangent, which is AB, and a radius meet, which is OE, a 90-degree angle is formed. So let's go to 90 minus 74, which will be how much? 16. When a tangent and A is formed. Come on, write it. Next, we are going to find CGF, right? CGF. C to G to F. Let me state here 74. Angles at a point on a straight line is equal to 180. So that means 74 plus this whole angle in the middle here, right? Plus 74 would add up to 180. So this angle will be what? Let's put CEF first. So CEF would be equal to 180 minus 74 plus 74. And what y'all got? So yeah, working out 32. If it's 32 degrees, CGF would be equal to 180 minus 32, which will give me what? 148. And the reason for this one here would be opposite angles in a cyclic quadrilateral, opposite add up to 180 degrees, right? So I just want to show you all a visual on this now, right? So we basically found CEF to be 32, right? So here's 32 degrees, right? Meaning that here's 16 and here was 16. So saying that these two triangles on either side are the same is correct to say, right? So if here's 32, this angle up here is the angle that is opposite to that angle. Both of them are in the quadrilateral, so this is a cyclic quadrilateral, right? All vertices are touching the circumference of the circle. So what do we get here to be? This was 148 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So from A harbor H, so you're coming from H and you're heading to these two places, right? So you're coming from H and the bearing of two ships, they leave harbor H right. And now trying to analyze the question. So from a harbor H, the bearing of two ships Q and R are 69 and 51 respectively, right? Meaning that for this one, the bearing that goes from the north line and goes to the line that goes from H to Q would be 69. And then the other one, you start at the north line, you're going in clockwise direction, and you go to the line that goes from H to R. That bearing would be 151 degrees, right? From H. So here would be 175 kilometers, right? Q is 175 kilometers from each. Right? Boom, bang. Right. So we have this angle, we have this angle, we have this side, we have this side, and they want us, well, obviously the first part was to complete the diagram, show the information. The second part is to find QR, the distance between the two ships, right? So we have two sides. We have side and side, and we could find this angle. You see, we could find this angle. We could find the angle. So you have side angle, and you want to find our side. What are we using? Cosine rule, right? Okay. So let me find this angle here, which is QHR first. That is the first thing I have to find here. QHR. So common A will be QR. That's what we're trying to find, right? And 242, and what's the next one? 175 squared minus 2 by 242 by 175. Right? Cos of the angle. Was the only angle? We didn't work it out. I can put the working right here now. Watch. I could simply put 151 minus 69 here. But I'm putting that in brackets. Alright? We got it here? Right. So QR will be equal to what?
278.21 kilometers.
Approximately equal to 278 km. How far due south is ship R of the port H, right? So you're at the port H, you want to know how far due south is R. So let me show you all how we work in this one, right? Okay? This line is, so we lining up with here, boom. What we forming here? A right angle. So let me call this S south, right? So if I want to find out how far due south R is from H, I need to find this side here, right? So what we could look at here, boy, this will be a straight line. So we have here what this angle was. This was how much? 82 degrees, right? So angles at a point on a straight line add up to how much all these angles will add up to? 180. So let's find SHR. SHR would be equal to 180 minus 151. You're not to add nothing. That's 180 minus 151. How much this to give you?
29.
Right? That is SHR, right? So SHR would be the angle that is within here. 29 degrees. But this is our right angle triangle. What side we trying to find here? We're trying to find our adjacent. And what here would be? This 242 is my hypotenuse. Right angle triangle, we can apply trigonometric ratios, right? Which is the only trigonometric ratio that uses SOHCAHTOA. Which one uses adjacent? This is adjacent. And hypotenuse, it would be CA, right? Cosine. CA is cosine, right? So there we go. We're going to line up cosine. Remember, the angle is 29 and the hypotenuse is 242. So the adjacent side is the side you're trying to find, right? So cos of the angle 29 will be equal to adjacent, which is the side you're trying to find, what we are calling it, HS, all over the hypotenuse, which was 242. Carry this to the left. What are you doing with it when you carry it to the left? Multiply 242 multiplied by cos 29 is equal to HS. What are we getting there?
211.66.
211.
66. Round off.
The diagram below shows a circle where AC is a diameter, right? A to C is the diameter, and B and D are 2 points on the circle, and DCE is a straight line, right? So D to C to E is a straight line. CAB is equal to 28, C to A to B is 28, and DBC is equal to 46, right? D to B to C. So calculate the value of each of the following, give detailed workings and a reason for your answer. So angle in a semicircle is equal to 90 degrees, right? So if this is a 90-degree triangle here, this angle, which is 46 plus the other angle here, would add up to 90 degrees, right? So DBA would be equal to 90 minus 46. What I'll give me 44.
Yeah, 44.
44 degrees, and the reason would be angle in a semi circle 90 degrees. Everybody good there? Right? So to find DAC, the angles in the same, well, at the circumference in the same segment are equal, right? We have the chord DC cutting the circle into two segments. These two angles, which will be 46, and this angle up here would be equal, right? The theorem would be angles at the circumference in the same segment are equal. So let me write that. Write out the theorem, please, guys. It would not stick, Angles are equal. B to C to E, right? B to C to E will be this angle on the outside here, right? But could we find this angle here?
Yep.
Right? This whole angle here, what do we, here's 46, right? The entire angle will be 46 plus 28, which will give me how much?
70.
74 degrees, right? That will be the whole angle. Opposite angles in a cyclic quadrilateral add up to 180. BCD will be equal to 180 minus 74, right? Which will give me 106 degrees, right? That reason will be opposite angles to 180 degrees. So therefore, BCE will be equal to 180 minus 106, which will give me 74 degrees, right? Angles at 180 degrees. So part B, the diagram below shows a quadrilateral PQRS, right? Where PQ and SR are parallel, right? So PQ and SR are parallel. So the outer quadrilateral is what? What is forms? It's a trapezium, right? It's a trapezium. They said SQ is 8, and then they said SPQ is 90, SQR is 82, S to Q to R, and then they said QSR is 30. Now you realize they did not know they put in 30, right? Boom. No, they did not put in this 90 here, but you have to know if you have a pair of parallel lines, this angle and this angle are co-interior angles, they add up to 180 degrees, right? So if here's 90, down here is 90. So find the length of PS. PS is here, right? Do we have this angle? PSQ, so let me write it right here. PSQ is equal to 90 minus 30 degrees, which will give me, right, so we have here 60 degrees, right? What can we use to find PS? What here will be? SQ will be my what? Because it's a right angle triangle, eh? And this will be my what? What formula that is? The cosine of the angle theta is equal to adjacent over hypotenuse, right? So the cosine of 60 is equal to adjacent, which is PS over hypotenuse, which is what? 8, you sure? So what you're doing here, kindness 80, and what you're doing with it, you multiply it, right? So 8 multiplied by cos 60 would give me PS. What are we getting PS to be? 4 flat
4 centimeters from there.
proper. So next we want to find the length of PQ. So let's scroll up. Right, PQ. What kind of easy question is this? Pythagoras theorem, what we just find here to be 4, and just found here to be 4. I see it as something to challenge us. So this is a side, not the hypotenuse. So if you want a side, that side squared will be equal to the hypotenuse squared minus the other side squared, right? So the other side will be 4, the hypotenuse will be 8. Let's work, right? So I'll go down here. So B squared, which is actually PQ squared will be equal to your hypotenuse squared minus the other side squared. So PQ will be equal to the square root of what? Because you have to do the opposite of square over here, which is square root. The square root of what? Square root of 48 is what?
6.93 centimeters off.
6.9 who?
3.
Centimeters. Trapezium PQRS, right? So you want the area. If you want the area of this trapezium, what is the formula for area of a trapezium?
A plus B by 8.
Trapezium. Yeah, I think he had it right. He just missed out the half, or he probably said before you unmute the mic, right? So it's a half of A plus B multiplied by height, right? A and B will be 2 parallel sides. Okay? Your height will be a perpendicular height from, well, the perpendicular distance from one parallel line to the next. So here will be a height. Okay? Now we already found here. What we found this to be? This was what? 6.93, right? So A is equal to 6.93 centimeters. What missing here? What are we using to find this by? We had to find this angle first, right? Because we'll use this and this, right? Okay? And then we'll have to use this and that. So we need to find this angle first. So let's find SRQ. 82 plus 30. And we're getting here? 68 degrees, right? Now we engage in 68 degrees and the side opposite to 68 degrees, right? 68 degrees, right? So 68 and 8. This will be capital R. Here will be common R. Here will be capital Q. Here will be common Q. It's like common Q over sine capital Q is equal to common R over sine capital R, right? What we're trying to find, SR, right? Capital Q will be 82. You all seen it there. Common Q would be SR. Capital Q would be sine of 82. Is equal to common R was what? 8 over sine of 68. This could come here. See, actually feel real generous to say. SR would be equal to 8 over sine 68 multiplied by sine 82. Right? When you work on this, make sure and put this in brackets. Open bracket 8 divided by sine 68, close bracket, multiplied by sine 82. What is SR equal to? 8.5 centimeters, right? So that 8.54 will be my other parallel line, right? 0.54 centimeters, right? We still need to find the area of this trapezium, right? How do we find the area of the trapezium? It's going to be a half by A plus B multiplied by height, right? So this is your common B. Everybody cool there? So let's look. Therefore, area of the trapezium would be equal to a half of A, which was, anyone could be A by the way, 6.93 plus 8 point how much? 0.54 multiplied by what was the height? 4, proper. When you work out this, what we get the area of the trapezium to be?
0.94 square centimeters.
30
Yeah, 30.94 square centimeters.
centimeters squared.